Hi guys, we're now going to be talking about some shortcuts that you can use to show that triangles are similar. So just like when we talked about congruent triangles, we had some shortcuts that would allow us to not have to show that all three sides and all three angles in your triangles have to be congruent. So just like what we were doing earlier we were having to show that all of your sides we were having to show that all of your sides were proportionate and all of your angles were congruent. Okay, well, instead of having to do all that, okay, we don't got time for that, right? So instead of having to do all that work, if you have triangles, there are some shortcuts. So the first one is the SSS. And that little tilde symbol means similarity. That's your similarity symbol. So SSS similarity says that if you can just show that three sides of one triangle are proportional to three sides that correspond to those sides in another triangle, then your triangles are similar. So if you can just show that three sides are proportionate that correspond to each other, then guess what? That is enough to show that your triangles are congruent. Like down here, I compared all three sides and showed that they all reduce down to 1/2. Okay, which means since the scale factors of all three sides were the same, that the triangles are similar. So if you can just show that three sides have the same scale factor between two similar figures or two figures that we don't know are similar, that is enough information to show that triangles are similar. Whoa, right? Holy hot dog, I know. Okay, another shortcut you can use, okay, this is the SAS similarity, which is very similar to the SAS congruent postulate. Just be careful when we're talking about similar triangles, your sides must be proportionate, not congruent. So if you can show that two sides of one triangle are proportional to two corresponding sides of another triangle, and if the angle in between the sides are congruent, then guess what, you guys? That is enough information to show that your triangles are similar. So like down here, I compared side AB to DE and side BC, side AC, JKLOL, side AC to DF. And I showed that they were proportionate, and I showed that the angle in between those two sides, angle A and D, were congruent. So if you can show that, that is a shortcut for showing your triangles are congruent. Cool beans, right? I know. Alright, and your final shortcut that we're going to talk about, this one we did not use at all in your congruent triangles. Guys, so remember, similar triangles are shapes that have the same shape but are different sizes. So guess what, you guys? If we know that all three angles are the same, okay, the angles kind of determine the shape of your triangle. So the shapes are the same if you know that all three angles are the same. It just might mean that the angles don't get extended as far, or maybe the angles go out further. Like if you see here, angle B, the angle kind of stops pretty quickly. But in this one, angle E, the angle is the same, but it just like kept going a little bit longer, which created a bigger triangle. Okay, so in similar triangles, technically AAA is enough to show that your triangles are similar, but you're probably like, Miss Long, can you read? Because right here it says AA, not AAA. Well, we can even create another shortcut, because if we know that two angles are congruent, by the third angle theorem, that must mean that the third angles are also congruent. So showing just two angles are congruent is actually enough information to show that your triangles are similar. Pretty neat, right? Okay, so like in this one, I showed that angle A and D are congruent as well as angle B and E. So if you can just show that two angles are congruent, your triangles are similar. So this is like a super shortcut, which is pretty cool. Okay, so in examples 5 through 10, what we're going to do, we're going to determine if the two triangles can be proven as similar, and if so, we'll state the similarity. So we're going to write a lovely similarity statement like down here. Remember that little tilde means similar. Okay, so we're going to write something like this. Okay, also we're going to describe or state the postulate or theorem we used to show they're congruent. So we're going to show they're congruent either by AA similarity, SAS similarity, or SSS similarity. Okay, so let's get going on these examples. We're going to start off with example 5. So let's get going on example 5. Okay, let me just make sure it's working. Come on, thing. Sorry, guys. Sometimes it doesn't want to cooperate. Come on, thing. Hold on. Sorry, guys. Come on, thing, work. Well, this is embarrassing. Jeez, my thing froze. Sorry, guys, let me try it again. Please work. Please. Okay, we're working now. You can see I'm in live motion now. Sorry about that, you guys. I think the demon cat's got my document camera. Okay, so we're good to go. Okay, so example 5. Let's get going. So again, I want to show that the two triangles are similar by either SSS similarity, SAS similarity, or AA similarity, which, who knows? They might not even be similar. So we have to decide. We're going to be like little detectives. We're going to figure out if these triangles are similar, and if they are, we're going to state how we know and the postulate we use to show that they're similar. Okay, well, let's get going, you guys. Okay, so usually when I do these problems, I kind of look at what's given to me, because that will kind of point me in the direction, okay? Doing similar triangles, in my opinion, is a little bit easier to figure out because we only have 3 options. We have SSS, so 3 sides, SAS, so 2 sides and an angle, and remember the angle has to be in between the 2 sides, and then we have AA, or angle, so 2 angles. So that's what we're looking for, which if I look at my picture, I'm given 2 side lengths, and I'm given that these 2 angles are right. So it's kind of looking like side, angle, side, a little bit, side, angle, side. So I don't know. I have a hunch that they might be similar by SAS, but we have to see. Don't forget, in similar triangles, your sides must be proportionate, or their scale factors must reduce down to the same number. So if they don't reduce down to the same number, your triangles aren't proportionate, which means they're not similar. So just be careful. Okay, so my hunch is that it's going to be a side, angle, side. But I don't know. Let's see. Okay, so I'm going to compare 2 sides first, which it doesn't matter which 2 sides. I'm going to start with 6, which if you guys see here, 6 is the smallest side given to me in this triangle. Okay, so when I do this, I'm going to compare it to the smallest side given to me in this triangle. So which side length is the smallest side in this triangle? It is the 12. So I'm going to put 6 over 12. So I'm trying to find my scale factor right now. Okay, which my 2 smaller sides are 6 and 12. So I'm going to divide 6 over 12. Okay, which that will reduce down to, do you guys know a number that will divide into 6 and 12? You guys are so smart. It is 6. I can divide both of these bad boys by 6. Okay, so 6 divided by 6 is a 1, and 12 divided by 6 is 2. Okay, so my scale factor is 1/2. And again, if I'm going to give a reason, it's because I know that the scale factor is 1/2 because these are the values that they gave me. So this is also because of the given. So I know that's my scale factor for these 2 sides because they were given to me. Okay, so I have a side. Okay, the next thing I see are 2 angles. Which one of these little boxy things mean? It means that they're right angles. So it was given to me that the angles are right, but we know that right angles are the same because they're both 90 degrees. So I know that angle B is congruent to angle F because, not because it was given to me, it was given to me that these are right angles. Okay, the reason why I know they're congruent is because all right angles are congruent. So all right angles are congruent. Okay, so sides must be proven proportionate. Angles must be proven congruent. So just be careful when you do similar figures. They're a little different than when we do congruent figures. So just be careful. Okay, so I have a side. I have an angle. I really hope that my final two sides are proportionate, because if so, my two triangles will be similar by SAS. So let's see what happens. Okay, so I'm going to find my next scale factor. So my next scale factor, I'm going to compare my two larger sides in my triangle, which are sides 7 and 14. So I'm going to divide 7 over 14. Okay, and guess what? We can reduce that bad boy down. Do you guys know a number that will divide into 7 and 14? Correct. That would be a 7. Okay, 7 divided by 7 is 1. And 14 divided by, that's a 7, sorry. 7. 14 divided by 7 is 2. Look at this, you guys. My scale factors are the same. Yes, that's a good thing. If these were different, I would already stop, because that means sides are not proportionate, but they're the same, so I can keep going. And again, the reason why I was able to find the scale factor is because, well, it was given to me. These two sides were given to me, so then I could find the scale factor. So this is also because of the given, if I'm going to give a reason. Okay, so now I have enough information. I have a side, then an angle, and then a side. My sides are proportionate and my angles are congruent. And the angles in between my two proportionate sides, which means my triangles are now similar by SAS similarity, which is pretty insane. I mean, I'm freaking out right now. That's so cool. Okay, so again, when we write our similarity statement, we must write it in a very specific order so that we know the corresponding sides and angles between the two similar figures. Okay, so I'm going to say triangle. I'm going to say ABC. Why not? This time I'm going to write similar. So I'm just going to do a tilde. And sorry, I know my B looks really embarrassing, so hopefully your B looks better. So triangle ABC is similar to triangle. Okay, so when I go around, if I trace my triangle ABC, I have my smallest side, then the right angle, and then my bigger side given to me. So small side, right angle, then big side. So I need to make sure I do this triangle in the same way. So if I go from my small side to the right angle to my large side, that would be EFD. So triangle E to the F to the D. And they are similar by SAS similarity. You must put the little tilde thing, the little wavy thing. I'm trying to do a wavy thing with my hand, but I'm failing. Okay, you gotta do the wavy thing at the end, because that means similarity. And that's how we know we're talking about similar triangles and not congruent triangles. When we don't have the little tilde thing, when we don't have the little fancy tilde, that means congruent. Now we're talking about similar. So don't forget to add the little tilde. And guess what, you guys? That one's done. Let's get going on example 6.